Hello friends, welcome to our channel Knowledge Amplifier. So in my previous video I have started discussion on handwritten character recognition and I have already shown you two very interesting feature extraction. One is aspect ratio, which is basically range along y direction, that is maximum of y value minus minimum of y value, divided by range along x direction, that is maximum of x value minus minimum of x value, right? But the problem with this aspect ratio and another input feature was duration. What we were getting as problem that these two input features was almost overlapping with other classes, and as a result it was difficult for our model to make proper prediction and accuracy decreased. Okay, so in this particular video let us try to explore and extract some more features which might be helpful for increasing the accuracy. Okay, so CLC clear all, close all, warning off. Okay, right? So x equal to, I am reading one data. Okay, so b1 dot text. Here let me just evaluate this particular part, and here let's check the dataset x. You can see that this is 23 cross 4 data, var1, var2, var3, var4, 4 columns. First column is indicating time. Okay, that is at 0th instant what are the values, at this instant what are these values, like that sampling has been done. All right, and then this var2 and var3, these are what? These are basically x and y coordinate values, and var4 is basically amount of pressure given at that particular point. Okay, let us visualize first what is this particular digit. Okay, sorry, character. So plot x dot var2, that is x direction value, comma x dot var3. If we just run evaluate selection, we will be getting this one. This is nothing but what? This is nothing but our English alphabet B. Okay, now aspect ratio let us compute like I have discussed earlier. So here let me give axis equal so that we can visualize properly next time. Aspect ratio equal to range along y direction, so x dot var3 by range along, x dot var2. So for this particular character the aspect ratio we are getting 2.0952, right? Okay, fine. Now let's try to extract some more features. Okay, so we have studied descriptive statistics, mean, median, variance, standard deviation, range, all those things, right? Now we also know that mean is highly affected by outliers. Okay, now the thing is that when you are writing any digit, okay, what will happen? Your hand might shake, okay, because it will obviously not take proper exact B shape. It is not possible because due to our nervous system, central nervous system, it might happen that there is some sudden deviation appearing in that handwritten character, right? So what we should do, instead of taking mean, we should go with median. Okay, and one more thing you can observe in this particular scenario, that this particular data is actually normalized such that it is having zero mean, because you can understand 0 along x direction is appearing here, 0 along y direction is appearing here. Okay, so the thing is that this is basically we have from our actual character we have subtracted the mean values of x direction and y direction, and then we have got this particular data. I just wanted to discuss this. So there is no meaning in computing mean along x or y direction, rather we can compute median. Okay, so median along x direction is equal to nothing but median of our x dot var2. But the thing is that if you check our dataset x, here some null value present, so we don't want to use this, so omitnan. Let us run this particular piece of code and let's check what is the median value we are getting. So if we just do evaluate selection, we are getting median along x direction is minus of 0.0538. Okay, right. Then what can be another feature? Median along y direction, obviously. Why we are not using mean? Because already it is the data set is such that it is having 0 mean and 0 mean along x direction and 0 mean along y direction. Okay, so here we can write var 3, right? So here median of y, what will be getting? We will be getting minus of 0.0336. This can be taken as another feature. Okay, then what extra thing we can do now? What is the span of these data points along x direction and y direction if you want to compute? Then obviously we can go with our variance, or we can go with our standard deviation like that. But you can use MAD also, that is mean absolute deviation. How much deviation actually happening with respect to mean? Okay, and this one I have discussed already while discussing outlier detection and handling outliers. Okay, imputing by some values like that. When I was discussing outliers, you can refer that data pre-processing stage. Alright, so this MAD, okay, that is mean absolute deviation, can also be treated as another feature. Okay, so what is that value? MAD of, maybe we can give along x direction. If you want to compute, then we can pass this one, and while computing mean absolute deviation, just write here HIL MAD, and here you will be getting the detailed data set. Okay, here see, returns mean absolute deviation of the value x. Okay, and you can explore from MATLAB documentation web version also. The thing is that, see, MAD treats nans as missing values and removes them. So like while computing median, we need to write this omitnan, but while calculating MAD, we no need to write that because it will automatically remove them. Okay, so x dot var. So this will be giving us mean absolute deviation along x direction, and this will be giving us mean absolute deviation along y direction. Okay, so what are those two values? Let us try to understand. See, those two values, deviation along x direction is 0.1519 and deviation along y direction is 0.4195. Okay, and you can just try to interpret these values with respect to this particular figure. You can understand in y direction the length is quite high compared to the span along x direction. Okay, so from mean, actually the x values are not that much going far away, but in y direction, as the length is quite big, so with respect to mean, it is y values are going far away. As a result, MAD, which is indicating basically span, okay, have more value in y direction but less value in x direction. Okay, so this can be also treated as a feature for training our machine learning model, because you can understand that this will be taking different values for different alphabets. Okay, so we have learned that some more important features like median values along x and y direction, and to calculate span we have computed MAD, mean absolute deviation of that. There is no meaning in computing mean, because you just simply write mean of maybe x dot var 2. Okay, here also we need to give omitnan. Okay, omitnan. Okay, you will be getting nothing but this value, which is basically quite small, and this is actually 0, but due to very high accuracy of computation, it is giving us very small value. If I take y direction mean value, this, then also we are getting like this. Actually, you can understand that this data is given such that average y direction value is also 0, average x direction value is also 0, and that you know how to achieve that. Any data set I am having, what I'll be doing, I'll be basically, suppose x is one particular column, what I'll be doing, I'll be subtracting mean of that particular column from each data point, and the newly created column, newly mapped column, after applying this particular formula on each element, will be getting such column for which mean will be 0, right? As simple as that. So I hope you have understood this. This is all for this video. Today in this video you have learned some more feature extraction from this kind of data set. The dataset and the code I'll be posting in the description box or in the comment section. If you want, you can go through that. Thank you. I'll be continuing this discussion in my upcoming videos. Till then, happy machine learning.